Okay, we're over here somewhere. We're over here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities. And we are looking at some tricky ones here. Let's look at 8.2. 8.2. Okay. Let's take a look at this. We got the absolute value of 20x minus 29 is less than negative 17. Is less than negative 17. What happens when we actually work this out algebraically? It's kind of the question. 20x, and I guess we'll do that, is less than negative 17. Okay? So let's go ahead and go over here to the magic board. I don't know, I don't know why I'm calling it magic board. Alright, so we have the absolute value of 20x minus 29 is less than negative 17. Now we'll go ahead and drop the absolute value bars. And solve for x. So we got negative 17 plus 29. And what do we got there? 9 and 3 is 12. So we got 20x is less than 12. X is less than 12 over 20. And therefore x is less than, and of course that's going to end up reducing down to 3/5 it looks like. X is less than 3/5. Now let's go over here and do the other side. So we have 20x minus 29. Flip the inequality and multiply that by negative, so that becomes positive 17. Now remember this guy right here, it's pointing to the left, so think of the word and, which is also associated with intersection. Okay, so let's go ahead now, solve for x here, 17 plus 29, and whoops, left off the x, didn't I? So 17 plus 29 is going to be 46. So we end up with 20x is greater than 46. X is greater than 46 over 20. And of course that easily reduces down to 23 over 10. So we have x is greater than 23 over 10. Now let's get, well, I guess we don't need to do that. I was going to get the decimal representation of both those numbers. Okay, so remember and also remember intersection. Okay, that's important here. X is less than 3/5. Let's see, let's just put 0 here. And we'll put 3/5 here. X is less than 3/5, and so, right, that'd be everything going off in that direction. Okay, now 23 over 10 is going to be a little larger. We'll put that over here, right, and we'll put an open, so you know what, we'll just do it right here. How's that? I guess this is what we're going to do. We're going to, I'm just going to, let's just put it here. So x is greater than, so everything going off in that direction there. Now, I want you to look at something here. We're using the word and. Okay? In other words, when we pick a number on the x-axis, it must satisfy both this inequality and this inequality here. And remember, it's intersection. Okay? And remember what intersection means. You know, what do both of these sets have in common? Now we're going to go ahead and write this set here, and of course it's intersected with this set, 23 over 10 to infinity. Okay. Now, if you took this set and you intersected it with this set, what do both these sets have in common? In other words, is there an x value that is both in here and also in here? Is there a number on the x-axis that's both in here and in here? Well, not in the real space. Okay, I'll just tell you that. And so guess what? This is actually equal to the empty set, or we could actually say no solution. This doesn't have a solution. It doesn't have a solution. And this is another, so this is a way to prove this, I guess. We could, this is a proof, sort of a proof, proving this. It doesn't have a solution. And let's now go back up to here. Well, remember that this output right here is either going to be 0 or greater than 0, right? I mean, it's got to be a number including 0. Greater than or equal to 0, this output is. What does this say? This is a negative number right here. Negative. There are no x values that you can plug into here that's going to be less than negative 17. There's not one. Not one. You can't find one. Forget it. Right? That's going to be less than negative 17. So immediately, this is no solution. Right? This has no solution. Or you could say empty set. Now there's really no way of writing this in interval notation that indicates an empty set that I know of, right? But there is a symbol out there. You can write this, or you can do squiggly brackets and write that right there. Okay, and didn't mean to click on that. So the solution set is empty. Now up here you could actually just type in that right there, and I don't know, yeah, I do have that program. So that circle with a line through it means empty set, and that's something that's talked about in the section on sets, the very first thing. Okay, so there you go. Another one of these problems, right? They could take up your time. You should just look at that and go, man, there's no solution to that, or the empty set. Okay, the interval that contains no elements. Right, so we're over here at gotomath.com. Check it out. See you later.